from the last class. Plus, we will be seeing how to calculate number of one and number of onto functions, problems based on them. Right? So I suggest everybody who is attending this class to give one try for this problem and let me know if you have any doubts in this. For this question, guys. Speak, please. Something. Yes, no. No response. Can you see the problem on my screen, right?
Yes, sir.
So, like, can you just tell me whether it is injective means one function, surjective means onto function? If you don't know, maybe let me write here. This is one. This is onto. Tell me. Just say don't know if you don't know. I'll teach.
Sir, neither one nor on.
Like that's what I'm asking whether it is one. If not one, then why it is not one? It is onto a. If it is not onto, why it is onto? I need the reason as well, not just the answer. I didn't got any response from you guys. I am only teaching. Please listen here. Like for injective nature or one nature, I am using counter example method to prove this one as not one or not injective. What is counter example means? I will take two distinct x1 and x2 belongs to real number and I will show that f of x1 is equals to f of x2, right? And x1 is not equals to x2. That means like two distinct real numbers has same image I'll prove, then it is not one, right? How to do that one? Like I can take like let us take x1 is equals to -1, x2 is equals to maybe let us take -2 here. So how
Sir,
much we will
fourth
get?
option. I'm getting
Fourth
as fourth
option.
option.
I think that is correct. Fourth option correct. Now, how much is f of x1 here? F of x1 will be equals to, we can write -1 plus square root of -1 whole square. If we do square of a -1, it becomes 1. A root of 1 will be same as 1. So -1 plus 1 is 0, right? So now f of -1 is equals to 0. Now what about f of minus 2. F of minus 2 will be equals to, we have, uh, we have minus 2 plus square root of minus 2 whole square. So minus 2 whole square, it will be plus 4. A root 4 value is plus 2. So minus 2 plus 2 is 0 here. Now I have proved here two distinct elements minus 1 and minus 2 are mapping to same image 0. Therefore, the function is not injective. If it is not injective, it cannot be bijective as well, right? So now for onto nature, if you can prove that a range is not equals to codomain, this is not onto or not surjective. If you cannot do that, again think about some counter example, and you, if you have any counter example like that, you are done in that, right? So in counter example, I can take any negative real number. For example, if I take f of x is equals to minus 1. What I am trying to do? I am taking minus 1 belongs to real numbers. That means codomain. There is an element minus 1 in the codomain that does not have any image. Class. Right? So like now f of x, if I substitute, that will be x plus square root of x square is equals to minus 1. I can take this one into two different cases. Case 1, when maybe before doing cases, let us write x plus modulus of x is equals to minus 1. Now break this one into two cases. Case 1, when x is greater than 0, we will be having x plus x is equals to minus 1. 2x is minus 1. X is minus 1 by 2. There is a solution, but like our assumption is x is positive. Now the solution what we got is not a valid solution, discarding this one, right? So after this, like maybe there is second case. In second case, we are taking that x as less than 0. If x is less than 0, this becomes x minus x will be minus 1. 0 is minus 1. We know that 0 is not equals to minus 1. It is not a valid solution. Therefore, I can say that the function is neither 1, 1 nor onto. In other words, it is not injective and not surjective as well. So this is the correct option. This option we should discard. Anybody has any doubts in this? Please do let me know.
No, sir.
Can we move to the next problem? Anybody writing this?
Yes, sir.
Okay, copy this, please. Yes, please. See, like, no. We will equate them, and if we can show that there is only one solution, that is x1 is equals to x2, then it is injective. Other than this, any other solution we have, that is not injective. That is analytical method or mathematical method we will call. You can use in your board exams that method. Yeah. Any other doubts? Anybody? Copied this one.
Yes, sir.
So now going to the next problem. Next problem, something like this, like you can see these kind of definitions as well, right? So where they'll give function in two different cases. What kind of function is given here? They have given function is from a real numbers to real numbers, and function f of x is equals to two different definitions is given, x into modulus of x minus 4 when x belongs to a rational, right? So whenever x is rational, we should use this case. Another thing is like x into modulus of x minus root 3. This is when x does not belongs to a rational. Does not belongs to rational na irrational number. Whenever we have a irrational number, we should use this definition. When they have given these kind of function, identifying the type of function means we are just checking one nature of the function, right? So one nature or injective nature. Like here, if you can think about a counter example, you can think. If you cannot think about a counter example, you can do analytical method, right? So here I am thinking about a counter example. For that, like how I got this idea, let us equate function f of x to 0. If f of x is equals to 0, then there arises two different cases. Case 1, when x belongs to rational, whenever x is a rational number, I will write x into modulus of x minus 4 is equals to 0. Thus, this becomes x into modulus of x is equals to plus 4. We learned that when we open the modulus, we should write plus minus. So it becomes x square or x into x. We should write x into plus minus x is equals to 4. Next, it becomes x square is equals to plus minus 4. We know only one is a valid solution, that is x square is equals to 4. From here, I'll get x is equals to plus minus 2 here. Alright, so one moment. That means in how many of them is working here? I think f of 2 is equals to, or f of minus 2 is equals to a 0. Now what did I prove here? I proved that there exist two different real numbers plus 2 and minus 2, both mapping to same image 0 here. Therefore the given function cannot be one function. One more argument is there. That argument here, what we will do is like we will take like irrational case 2. Let us consider when x belongs to irrational. Whenever x belongs to irrational q complement, the definition of f of x is x into modulus of x minus a root 3. If I equate this one to 0, x into modulus of x is equals to root 3. If I solve this equation, I'll get x square is equals to plus root 3, x is equals to plus minus 3 power 1 by 4. Again, I have like two different elements in the irrational numbers as well, where both mapping to 0. Do you understand this one, guys? Anybody has doubts in this? Some doubts in this?
Sir, can you please explain from first, sir?
Uh, from first, why what's wrong in this?
So I wasn't able to connect.
Okay, wait, please wait. Let me remove these all things then.
Sir,
Yes, please.
how you decided taking this counter example, sir?
Counter example thing I will be knowing by trying. See, like if you didn't like this counter example method, you can also do different way. What is the different way? The analytical way you would have seen in NCRT or you would have seen in your boards. Proving a function one or not. Right? Let us take the conventional way. Maybe the counter example is little trickier for you to understand. In conventional way, let us assume x1 and x2 belongs to rational. When two rational numbers I have taken, and then like I will assume here f of x1 is equals to f of x2. If I can prove that it has more than one solution, then it is not a one function, right? Let us try that one. This will be x1 into modulus of x1 minus 4 is equals to x2 into modulus of x2 minus 4. Till here, any doubts? Anybody?
No, sir.
So like we are cancelling minus 4 on both sides. We have like both sides there is modulus. Even though there is modulus in both sides, when we are opening the modulus, we just write plus minus one side. That becomes x1 square is equals to plus minus x2 square. Anyway, it cannot be minus x2 square. So we are considering x1 square is equals to x2 square. Now what this one here states that? It states that we have two solution. One is x1 is equals to x2. Another is x1 is equals to minus x2. Hariharan, see, listen here. Now counter example I got idea from here. If I take two rational numbers, one is positive, another is negative. Let us take x1 is equals to 1 and then x2 is equals to minus 1. Let us calculate how much is f of 1. F of 1 is equals to 1 into modulus of 1 minus 4. This becomes 1 minus 4, which is minus 3. F of minus 1 also we are doing. That will be minus 1 into what we get modulus of minus 1 and then one moment, it is not working. Why it is not working? It becomes minus 1. One moment, it is not working here. This one. It is not working. This one seems not working. Give me a moment. Here also cases I need to divide, I guess. That many cases is not suggested. These many cases, like too many cases and all, it is coming. That many cases is not suggested. I'm just trying how many roots this equation has. If this equation has only one root, then it is 1, 1. Or else it is not 1, 1, more than one root. Right? In this way, it will be better. Case 1, when x is a rational number, or maybe when both this x1 and x2 are rational numbers. No. X is a rational number will do. We have like x into modulus of x minus 4 is 0. X into modulus of x is equals to 4. This becomes like x square is equals to plus 4 or minus 4. So like x square is equals to plus 4, we can consider x is equals plus minus 2. That means like we have only one will work, I guess. How much is f of 2 here? F of 2 is 2 into modulus of 2 minus 4. This becomes 0. But f of minus 2 becomes it is minus 2 into modulus of minus 2 minus 4. This becomes minus 8 not equal 0. Right? So in second case, let us take when x is an irrational. If we are taking x belongs to q dash q complement, in that case it is x into modulus of x minus root 3 is equals to 0. This becomes x into modulus is equals to a root 3. Right. Next it will be x square is equals to plus minus root 3. X square is equals to root 3. Now x is plus minus 3 power 1 by 4. Again we can check that when it is equals to f of 3 power 1 by 4, this becomes 3 power 1 by 4 into modulus 3 power 1 by 4 minus a root 3. So this will be 3 power 1 by 2 minus root 3. This is 0, right? I think f of minus 3 power 1 by 4, we won't get equals to 0. Now here I have two things. One is like when x1 is equals to 2 and x2 is equals to 3 power 1 by 4, we have f of 2 is equals to f of 3 power 1 by 4 is equals to 0. This implies this function is many one function. Now you guys understood this?
Yes, sir.
Please copy this. Hariharan, any doubt in this?
Sir,
Yes.
what mean that in this counter example, sir? If we
Counter
take
example na, see, we are giving two numbers having same image. We need to think two numbers which can have same image for the given function.
okay, sir.
So like here, I am like counter example na proving that it is not true by giving some example.
Okay, sir.
So like I have seen, no, here we have seen for two different elements, 2 and 3 power 1 by 4, it is having same image.
Yes, sir.
Hmm.
Then it become many one function, sir.
Yes.
Okay, sir. Clear, sir.
Any other doubts? Can we move to the next problem, guys? Everybody copied this problem.
Yes, sir.
Next problem is this one. This one is a problem, example problem from our book. It example 15, it is again a book problem. There are two parts given in this, right? So like in both the parts, they are asking like, let's say given function. F is given from real to real. I'll teach you part one. Please try part two at home, right? So in part one, given function is f of x. That one is equals to x cube plus x square plus a into x plus 4. Like let function is biject2, then a is. They have given that f of x is biject2. If function is biject2 function, we can say that f of x is 1 function. First of all, this is 1 function we are taking here. So if a function is 1 function, I can say that f of x is increasing or decreasing function. Increasing or decreasing function. So like increasing or decreasing, what I can say, f dash of x will be greater than or equals to 0 for all x belongs to real. One more possibility is there, it can be decreasing for that f dash of x is less than or equals to 0 for all x belongs to real. Equality can be at the points not in the interval. Clear? So now we are differentiating the given function. Can you guys tell me how much is f dash of x for this function?
3x square plus 2x plus a, sir.
Yes, 3x square plus 2x plus a. See, like they have already mentioned it is 1 function. That means this function should be either increasing or a decreasing function. Now, listen carefully. This is a quadratic equation. This quadratic equation should be either greater than 0 or less than 0. I am taking the possibilities. Possibility number 1, the quadratic equation can have two real roots. If there are two real roots, what it happens? It is an upward parabola. This is what you will be having in this case. This quadratic equation will be negative in between the roots and positive less than and greater than roots, right? If the quadratic equation has two real roots, this is the sign of f dash. If this is the sign of f dash, it is neither strictly increasing nor strictly decreasing in the set of real numbers, right? So the second situation is like the function can have, like the quadratic equation can have two roots which are real and equal. So in this case, it is positive and then positive and then positive. A zero occurs at one point, that is alpha. There is one more case. In that case, the quadratic equation has no real roots. In this case, it will be completely lying above. Now the sign of f dash will be positive everywhere. Do you understand this argument, guys?
Yes, sir.
Yes,
So
sir.
now like we need to make sure this function f dash of x or this f dash of x can be always positive, but this cannot be always negative, that I can see in the diagram. This is case 1, this is case 2, and the last one is case 3. In case 2 and 3, the function is always positive f dash of x. That means I can say this quadratic equation can have no real roots or equal real roots. If discriminant is less than or equals to 0, then f dash of x is greater than or equals to 0. Any doubt in this one, guys?
Sir, should we not consider f dash of x equal to 0, sir?
We can consider, no, there is no problem in that. Even though f dash of x is equals to 0. In this case, what happens na? Equal roots case, we can write f dash of x is equals to x minus alpha whole square, which will be always greater than or equals to 0 only, no?
Yes, sir.
Always greater than or equals to 0 means the function is increasing function, right? Now the function f dash of x to be increasing thing, we should make sure the discriminant is less than 0 or equals to 0. Discriminant is b square minus 4ac is less than or equals to 0, that is 4 minus 4 times 3 into a is less than or equals to 0. It becomes 1 minus 3a is less than or equals to 0. Now, a should be greater than or equals to 1 by 3. I can write that a belongs to closed bracket 1 by 3 to infinity. This is the interval of a. I can take any value from this interval. I'll be having a 1 1 function. If I take 0 and all, I won't be having a 1 1 function. Clear? Any doubt in this?
No, sir.
Eh, So like now, yesterday I have given you a note point. What that note point says, the range of a cubic polynomial, if not only cubic polynomial, let us say f of x is a odd degree polynomial. If f of x is a odd degree polynomial, then the range of f of x will be always minus infinity to plus infinity. Can add this one to the yesterday's point, right? If the function f of x is a odd degree polynomial function, then the range is minus infinity to plus infinity, right? So I can see that this is a given thing is odd degree polynomial degree 3. So I can write that range of the function f of x is minus infinity to plus infinity, right? Only one restriction, that is for a should be 1 by 3 to infinity. You guys understood this argument? If you have any doubt in any step, please do let me know. Anybody, online students, any doubts in this? Thank you for responding. Please copy this one.
Sir, can you
Yes, please.
explain why we are equating to discriminant to less than or equal to 0?
Uh, See, like, just listen to me here carefully. We say a function f of x is increasing if f dash of x is greater than or equals to 0 for all x belongs to a real, right? Vice versa also I can take. We say that if f dash of x is greater than or equals to 0, then function is increasing. This is a two-sided statement, right? So I know that the given function is bijective function mentioned in the problem. If it is a bijective, I wrote that it should be 1 1 function. If it is 1 1 function, it can be increasing or it can be decreasing. There are two possibilities here. I wrote uh, either f dash of x is always greater than or equals to 0 or f dash of x is always less than or equals to 0, right? Now after differentiating we have a quadratic equation, right? Now this quadratic equation, like from sign of a quadratic equation, this quadratic equation can have positive, negative and positive if it has two real and distinct roots. Whenever the quadratic equation has two real and distinct roots, it can be positive, negative and positive both as well. If this is happening in this case, f dash of x is not always greater than 0 and not always less than 0. This implies f dash of x is neither increasing nor decreasing, it is not 1 1, right? So, but f of x is 1 1, discarding this case. Now, the second and third case, if you observe, in second and third case, the graph of f dash of x is always lying above the axis, x axis. What does that mean? That means y value is either equals to 0 or greater than 0. Y is nothing but our f dash of x. That will be always positive. Always positive means that is a increasing function, right? So like I'm assuming discriminant is less than 0 so that there is no both increasing and decreasing in the real numbers, only increasing will be having.
Thank you, sir.
Thank you, please. Everybody copied this? Any doubt in this?
No, sir.
Okay, like second one also I'll explain. Please do listen. Like I think this increasing, decreasing, you guys are taking more time. In the second part, pay attention here. They have given function f of x is equals to a into x cube plus b into x square plus c into x plus d here. Now, a, b, c, d belongs to real. If this is a cubic equation, in that case, a cannot be equals to 0. Now, there is no doubt that it is onto. I can clearly see since it is a cubic equation, a range will be minus infinity to plus infinity. Codomain of the function is equals to range of the function. Therefore, the given function is onto. There is no doubt. The doubt is 1 1. We need to prove that or we need to get the condition when it will be 1 1. If the function is 1 1, right? If the function f of x is 1 1 function, then f dash of x is greater than or equals to 0 or f dash of x is less than or equals to 0. Both can happen. Listen how. Let us find f dash of x. F dash of x is equals to 3a into x square plus 2b into x plus c, right? So now I have like next what I used to do, I will find the roots of the first derivative. After finding the roots, I will mark them in a number line. If I mark them in a number line, like next I will do plus, minus, I'll check and I will do, right? Here, since I don't know about the ABC here, I'm not finding the roots and I'm not going that way, right? Imagine that, like, assume that if a is greater than 0, right? We are taking an upward parabola. Upward parabola can be three types, right? What are the three types? Please listen carefully. Case 1, a greater than 0, our upward parabola can have two real roots. Roots are alpha and beta. If the f dash of x has two real roots, in that case, f dash of x will be positive less than alpha. It will be negative in between alpha and beta. It will be positive again. In this case, you take any point less than of alpha, it is greater than 0. That implies in this interval function is increasing, in this interval function is decreasing, in this interval again function is increasing. Throughout the real number, if I observe, the function is neither increasing nor decreasing. That means function cannot be one function. So given quadratic equation cannot have two real roots. Then if it cannot have two real roots, what it can have? Let us take a situation when the quadratic equation has two real and equal roots. In this case, we have like roots are there, but only one point it is touching the axis, that is alpha. If I take any value less than alpha, it is positive quadratic equation lying above. Greater than alpha also, it is positive, it is lying above. If it is positive means function is a increasing function in the real numbers. If it is increasing function, we can say it can be one function, right? The last case, when the function has no real roots, everything is above. In that case, like no real roots, now always lying above the y equals 0 line, it is positive in all the for all real values. Now here also it is increasing function in the domain. Therefore, we can have either equal roots, that is discriminant equals 0. We can have no real roots, right? So what we should do, we should do discriminant is less than or equals to 0. Discriminant is less than or equals to 0 implies that like b square minus 4ac, we get 4b square minus 4 times 3a into c is less than or equals to 0. It becomes b square minus 3ac is less than or equals to 0. This is the condition needed in this problem. We need to write here a belongs to real numbers excluding 0. Do you guys understand this one? Need more explanation in this?
No, sir.
Thank you for responding. Please copy this. Please unmute yourself if you have any doubt in this and please ask. You guys copied this one. Can I scroll down?
Yes, sir.
Fully copied?
Yes, sir.
Then we are going to a concept today. In this concept, we are going to learn how to calculate number of one functions and number of onto functions, right? So we have problems in our JEE Mains PYQs based on this concept. Like I am trying to make this one simple. Please pay attention. If we have like, let us take two sets n of A and B. A and B are two non-empty finite sets. So in this like, let us assume number of elements in set A is equals to m and number of elements in set B is equals to n, right? So first of all, if anybody knows answer to this question, you can answer. Number of functions from A to B will be equals to how many? If you know, please unmute yourself and answer. Nobody saying anything. I should assume? You guys don't know, huh?
N power M, sir.
N power ms. Perfect. Remaining guys, don't know. Say something, no? Let's say number of functions from B to A is equals to m to the power n. Always here we will write the second set to the power first set. Second set to the power first set. This modulus means number of elements in that. Right? So the third one, number of one functions. This has three different cases. Let us prove this and write the formulas. I'm considering in case 1, number of elements in set A is less than number of elements in set B. Now, like onto one functions is nothing but like every distinct element in set A should have distinct image, right? Keep this one in mind. In set A, we have A1, A2, A3 and so on going till AN. In set B we have B1, B2, B3 and so on going till Bn, right? So like what does this mean? We have like elements is lesser than images, right? So in another words, we have more images than elements. Like listen to me carefully. Number of one functions will be equals to in this case you guys have seen in permutation and combination when we have like uh, this many m number of this balls, we have n number of boxes. Balls and boxes concept here I am applying. Out of these n boxes I am selecting m from this, and then inside that m we are dropping this m balls. Like listen carefully, we are selecting like from set B, select small m number of elements. There are n. So from n we are selecting m. This is NCM. Now this m elements we can map with m things, that is m factorial. This is like NPM. Clear? Like this formula is NPM. This is valid only if m is less than n. We will get n factorial when m is equals to n. We'll get 0 when m is greater than n. Why 0? You take an example where you have like 5 elements in set A and only 3 elements in set B. B1, B2, B3. If we are trying to do the 1-1 mapping, we won't be having a 1-1 mapping in this. Now the remaining 2 elements A4 and A5, we should map to at least 2 of like maybe 1. If you do the mapping here, at least one has 2 different elements, 2 different images, right? So it cannot be 1-1 in this case. This is about number of 1-1 function, right? So the number of onto function, we don't have a formula. We use a concept, right? There is a formula that is complex one. What I do is I use a concept that I will teach here. Can you copy this one quickly? If you have any doubt,
Sir,
please let me know. Yes, please.
sir, can you explain how you found the number of one function in case one?
One moment, please. Maybe do you know little bit permutation and combination?
Yes, sir.
So now listen, right? First of all, we have two things. We need to make sure every element of set A has a image in set B, unique image in set B. We are making it is a function. Second thing is like no two elements, I mean no two distinct elements has same image. That too I am keeping in mind and I am doing like first let us do number of chances for A1. How many options A1 has? A1 can map to B1 or A1 can map to B2, A1 can map to B3 and so on. A1 can map to Bn. I have n different chances for A1. Any doubt in this? Do you understand this line?
Yes, sir.
Now, similarly, number of chances for A2. If I take A2 here, listen carefully, right? Now I cannot write n here. Why? Because let's say A1 is mapped to B1, I cannot map A2 to B1 again. If I map A2 to B1 here, the function is not 1-1. So now how many chances A2 has? A2 has n minus 1 chance. Is this clear? Any doubt in this?
No, sir.
So now similarly number of chances for A3 we are doing. So now A3 has n minus 2 because like these two elements again I cannot pick B1 and B2 and so on we are going. Number of chances for AM, the last element, this will be n minus total number of images already got mapped. This is what I'll be having. Right? Any doubt in this any step?
No, sir. Clear.
Then we are seeing like using principle of multiplication, every element should have a image, no? So number of 1-1 functions we are doing. Number of 1-1 functions will be equals to n into n minus 1 into n minus 2 and so on. We have n minus m minus 1 here, right? This is what we have. Understood till now?
Yes, sir.
So like now what we are doing is like for this thing, let us multiply n minus m factorial and divide n minus m factorial. So this becomes n minus m plus 1 into n minus m factorial I multiplied and then I divided n minus m factorial. Now like listen the numerator if you observe like so starting from n going till n minus m plus 1. Maybe if I continue, this is n minus 1, n minus 2, and so on. This is n minus m plus 1 into n minus m into n minus m minus 1, and so on. We can go 2 and 1 divided by n minus m factorial. The numerator we can write as, right? The numerator is equals to n factorial, the denominator is n minus m factorial. This is nothing but npm. This is valid only if m is less than or equals to n. Again, 0 less than or equals, m is less than or equals to n. In other cases, this is not valid. So now do you understand?
Yes, sir.
You can copy this. Anybody has any other doubts in this?
No, sir.
Thank you. Can I scroll up the formulas you wrote? 1, 2, 3.
Yes, sir.
Everybody copied this slide.
Yes, sir.
Now there is a formula given for number of onto functions. Proof is like very difficult. Even I'm not sure. So I'm just giving you as a formula. Number of onto functions from A to B will be equals to, here also we have the case, right? So we have, this will be equals to one big formula, summation r is starting 1 going till n minus 1 power n minus r into ncr into r power m. So like this is valid if 1 less than or equals to n less than or equals to m, maybe n less than m, you write. N factorial we will get when n is equals to m. Another case we will get 0. This is when n is greater than m. Write this formula. Now we will solve some problems on this. Everybody copied this. Can I move to the problems?
Yes, sir.
So now we'll see the problems. This is the first problem we are going to see today.
Sir.
Like, yes, please.
That formula n should be only greater than m also.
Which formula? This
The
one.
number of onto functions. For
Uh,
that above first formula.
this one. One moment, please. You're telling this one.
Yes, sir.
Here n is less than m only. No. If we take like, for example, if we are taking a situation like n means number of elements in set B. Number of elements in set A is small m. So like you are telling opposite here. Correct? So
Yes,
if
sir.
I take, let us take A is equals to 3, B is equals to 5, right? So your situation I have taken a n is greater than m. This case only, no? So now
Yes.
if I try to do the onto function, what happens in this case? In this case, 1, 2, 3. This is the A1, A2, A3, A4 and A5. See, like 3 elements in a function, I can map to only 3 images, no? If I do in that way, there are like 2 elements, A4 and A5 does not have any pre-image. If it does not have any pre-image, this function is into function. Understood?
Okay, sir.
Hmm. So now here is the problem. This problem like 1 and on 2 thing they are asking, they asked in the advance. Based on formula we can solve, right? Given thing I'm writing, let us say set x has 5 elements. So n of x is equals to 5. Set y has 7 elements. N of y is equals to 7. If alpha is number of 1 functions, number of 1 functions from x to y, right? So in this case, like listen carefully. We are taking 5 elements in set X. That 5 elements we can say as x1, x2, x3, x4 and x5. And y is given here. Y has 7 elements. So in set y, we are taking y1, y2, y7, right? So you can do the conventional way, right? There are 5 different balls, right? This 5 balls we can keep among 7 boxes. The restriction is one box can hold only one ball, right? So like one more thing, like only one ball is we can keep inside one box. In that way we can do, right? So now first of all, out of the 7 boxes I am selecting 5. Listen carefully. If there are 7 distinct things, we are selecting 5 na, that is 7C5. Now the arrangements of 5 balls in this 5 boxes, that is 5 factorial. This is one way of doing. We will get like 7 factorial by 2 factorial. Another way of doing here is like you take the element x1. The element x1 has how many chances? It has 7 chances. X2 has 6 chances. X3 has 5 chances. And then x4 has 4 chances. X5 has 3 chances. This is 7 factorial by 2 factorial. Right? Understood this one? Anybody has doubt in this?
No, sir.
Thank you for responding. Like 1 functions we got, alpha we have, that is 7 factorial by 2 factorial. Now what is beta? They have mentioned that beta is the number of onto functions from y to x. They have given that beta is equals to number of onto functions from y 2x, right? So number of onto functions, if you remember the formula, you can use it. If you didn't remember the formula, what I will do is like I will use divisions and distributions of permutation and combination, right? In set Y, we have 7 elements, y1, y2 dot dot y7. In set X, we have 5 elements, x1, x2 dot dot x5 here. Now we are dividing the 7 elements among these 5 elements, right? In such a way that every X got at least one pre-image like that, right? So division and distribution of 7 things. The 7 things we can write like maybe everybody is getting 1 plus 1, 3, 4. The last one is getting 3. This is one case. And then the next case it is 1 plus 1 and then again 1. Remaining 2 are getting 2 each. Right? This is partitions I am writing here. 7 partitions in case 1. This is partitions of number 7 in case 2. Now I am going to divide and distribute in this manner. Uh, right, case 1, 7 things we are dividing as 1, 1, 1, again 1. This is 3 here. Can anybody from online tell me how we will divide 7 things as a group of 1, 1, 1, 1 and 3? You will be answering if you attended permutation and combination here. Number of onto functions is equals to 7 factorial by 3 factorial into 1 factorial power 4. Now we are dividing this 1, 1, 1, 1 and then 3 among 5. So this becomes 5 factorial by 4 factorial. Do you understand this one? First of all, do you know this partitions method and all?
Yes, sir.
So then you will be understanding. This becomes 7 factorial into 5 by 3 factorial, that is 6. Case 1 this is. Now in case 2 if I do, right, in case 2 there are
Sir,
again 7. Yes please.
can you explain why you have included 5 factorial by 4 factorials?
I should distribute, no? This first thing is division. Second thing is distributing them among 5% or 5 elements. In that distributing things, 1, 1 and then again 4 are identical, no? That's why 5
Yes.
factorial by 4 factorial. Now number of onto function in this case, partitions I already wrote above. Number of onto functions will be equals to, this is 7 factorial by 1 factorial whole cube 2 factorial whole square. This is divisions. Distributions is 5 factorial by 3 factorial into 2 factorial. This becomes 7 factorial into 120 by 8 into 6. This is like 8 ones are 8 15s are 3 2s are 3 5s are. We have 5 into 7 factorial by 2. Adding them we will get beta, right? So now beta is equals to 7 into 6 into 5 factorial into 5 divided by 6. So 6 gone plus 5 into 7 into 6 into 5 factorial by 2. 2 ones are 2 threes are. This becomes 35 into 5 factorial plus 35 into 3 sounds 105 into 5 factorial. This overall beta value we got is 1, how much? 40, yeah, 140 into 5 factorial. This is beta. Now alpha, I think we need to simplify. Alpha, we didn't do that. This is 7 into 6 into 5 factorial by 2. So we get 21 into 5 factorial. This is alpha we have. Now we need to calculate 1 by 5 factorial into beta minus alpha. This becomes 1 by 5 factorial into 140 minus 1. How much is this? 140 into 5 factorial, sorry. Minus 21 into 5 factorial. 5 factorial got cancelled. 140 minus 21. This is 119. Let me know any doubts in this if you have.
Sir,
Yes, please.
can you teach me the partition, sir?
Partition. You do one thing. You calculate this beta value using the formula.
Okay, sir.
Hmm. Do you understand how I calculated alpha here?
Yes, sir.
This beta partition method I am using permutation and combination of 11th grade. If you didn't attended those classes, it is difficult.
Okay, sir.
Hmm.
Sir, can you please show the question once, sir?
This is section G problem you will be having in the book. Everybody copied this.
Sir, no, sir, 1 minute.
Okay.
Copy it, sir.
See these kind of problems recently they are asking in JEE mains. They have given two sets A and B, and they are asking like then the number of functions from A to B satisfying. Like we need to make sure not only functions. If they are asking only functions, n of A is equals to 5 here and n of B is equals to 6 here without any restriction. Number of functions from set A to set B using the formula we are writing that will be equals to 6 to the power 5. I used like set B to the power set A here. Right? But they don't want this. What they want, they have given a clear restriction which says that f of 1 plus f of 2 is equals to f of 4 minus 1. Under this restriction, we need to calculate number of functions. See, like listen to me carefully, like here, the minimum we can make of f of 1 and f of 2. F of 1 plus f of 2 minimum value we are considering the minimum we can make like we can make this one is equals to 2 when both f of 1 and f of 2 is equals to 1 in that case I'll be having minimum. Do you understand this? The maximum of f of 1 and f of 2 we can make is 12 here, right? So 6 plus 6 I have taken like I got some idea like where f of 4 minus 1 can be, right? So now I'm dividing this one into cases. Case number 1, yes please. When both f of 1 and f of 2 is equals to 6, in that case it is 12 only, no? That is the maximum we can make. No, no, not A. B you can see, no? B. Set B. Now 6 is there, no? In set B. Then it is 12 only, no? Right? So, case 1, we are considering the maximum value that we can for f of 4. F of 4 can be 6. If f of 4 is equals to 6, then f of 1 plus f of 2 is equals to 6 minus 1. So I need to make sure f of 1 plus f of 2 is equals to 5. So can you tell me the order pairs for f of 1 and f of 2? One order pair is 1 comma 4. 1 comma 4 means f of 1 is mapping to 1, f of 2 is mapping to 4. Next order pair is 4 comma 1. After this we will be having 2 comma 3. After 2 comma 3 we have 3 comma 2 here. I think like 1, 2, 3, 4 chances we have in this case. Right? Any doubt in this? Anybody? How I wrote these all things?
No, sir.
So now
Sir,
number of yes, please. Any doubt?
yes, sir. Can you repeat me this one more time, sir? Order pair.
Like, see, f of 1 plus f of 2 is equals to 5 na. F of 1 can be 1 and then f of 2 is 4, right? So
Okay,
in that case, we'll be having this and we can switch, no, 4 and 1 we can take. We can switch again like 2 and 3, 3 and 2 in this way, right? So now the number of functions, if I want, like listen to me carefully, there is only one chance for f of 4, that should be 6. Clear? This one is for f of 4. Next, I have 1, 2, 3, 4 different chances for both f of 1 and f of 2, right? After finishing them, like we already mapped 1, we already mapped 2, we already mapped 4. Now, unmapped things are 3 and 5. Since they are asking about the functions, we can say 3 has 6 chances, 5 also has 6 chances. So 6 into 6 I wrote. This becomes 4 into 36. 4 into 36 is 144. Do you understand this one? Any doubts in this?
no, sir.
So like now I am giving in second case what you should do is like you should take f of 4 is equals to 5, right? After that, in third case you should take f of 4 is equals to 4. Like, and then this is last and final case, case 4. Here we can take f of 4 is equals to 3, right? So you guys copy till here and try these cases at home. Am I clear? Am I clear, guys?
Yes,
Yes,
sir.
sir.
Please copy this one. Then try remaining cases at home. Tomorrow there is no doubt class. Again, Thursday, 4 o'clock to 5:20 we will arrange. I have one request to you, whoever attending. I cannot see your faces. So like, please unmute yourself and express whether you understood or not understood. Right? So copy this problem and you can leave this meeting. You can join your next class.